Hi everyone, my name is Pratik Patil. My student ID is 2318118. So our model name is Real Estate Price Prediction. So let's introduce to our project background. Our project is called as Real Estate Price Prediction. The main motive of this model is to predict the price of the property with more accuracy. So as we all know that in the previous days our real estate agencies used to predict the price manually. So what happens when we predict the price manually? There are high chances that the predicted price could not be that much accurate. So suppose there is a XYZ real estate agency. In the previous date, what would the agency used to do is that they used to have a department of employees working to predict the price manually. So they used to predict the price manually. This used to cause a lot of error, and that error used to cause a lot of money to the agencies. So let's have a look to our problem statement. The main and the topmost problem of the agency is not getting any loss, and the reason for that is that loss is less accuracy. So here is a look of our data set. So our dataset has been gathered from Kaggle. It consists of 1041 rows and 14 columns. The size of the dataset is 15 MB. The feature I like about the dataset is that it has given CRIM, that is categorizing the price of the house on the crime rate happening in that particular area. So methodology. We have used three techniques in this model. The first technique we have used is linear regression. The second is decision tree regressor, and the third is random forest regressor. Let's have a look at the linear regression technique. Linear regression technique is a straightforward interpretable technique used for predicting a numeric outcome such as real estate prices based on one or more input features. Now let's have a look of decision tree regressor. Decision tree regressor are versatile and non-linear models that recursively split the data based on the features. Decision trees are useful when the relationship between the features and real estate prices is non-linear or involves interaction between the features. They automatically handle feature interaction and can capture decision boundaries effectively. The third technique we use in the model is random forest regressor. Random forest is an ensemble learning model that builds multiple decision trees and combines in prediction to improve overall performance and robustness. Random forest is an effective in dealing with complex data set and provide better generalization by reducing overfitting. It also offers features importance scores allowing you to identify key predictors. The main motive is data processing. We have taken many steps for data processing. It includes handling missing data, identifying and address missing values in a dataset. Depending on the extent of missing data, you may choose to input missing values using method like mean or median imputation, or you may decide to remove rows and columns with missing values. The second is feature scaling. Normalize or standardize numerical features to bring them to a similar scale. This is important for model like linear regression where the magnitude of coefficient depends on the scale of input features. Create new features. Create new feature or transform existing one to extract valuable information that may enhance the model's predictive capabilities. These pre-processing steps contribute to prepare the dataset for training machine learning models, ensuring that the model can learn meaningful patterns and make accurate prediction. The specific steps taken may vary based on the character of the dataset and the requirement of a real estate price prediction models. So let's have a look at model development. First is data exploring and analysis. Explore the dataset to understand its structure, distribution of features, and relationship between variables. Analyze descriptive statistics, visualize features, distributions, and identify potential correlation using scatter plotter and correlation matrix. The second is train test split, and the third is cross validate. Now let's have a look at train test split. Splitting the dataset into training and testing sets. The training set is used to train the model, and the testing set is used to evaluate its performance on unseen data. I think the train test split is the main aspect of this model. Cross validation. Implement k-fold cross validation to obtain more robust performance estimates to each model. Evaluate each model's performance using appropriate regression metrics, that is mean squared error, mean, absolute error. A throughout analysis has been carried out. So let's have a look to the conclusion. A thorough analysis has been carried out to comprehend and utilize the dynamic of the real estate dataset in the goal of creating a real estate price prediction model. Data exploring was the first step in the journey, providing important insight into the structure, feature distribution, and correlation of the dataset. The guarantee of the accuracy and robustness of the model, careful data cleaning and pre-processing were done after that. Also, I would like to tell that throughout the analysis, it became evident that random forest regressor outshone its counterpart. That is, in all the three models, we have seen that the random forest has been the most accurate one.